sac132-2. We had two sound sources producing waves of about the same amplitude in a room. Speed of sound in the air in the room is 343 meters per second. Get a beat frequency of 2.8 hertz. And one of the sources is known to be producing sound whose wavelength in air is 53 centimeters. The other is producing sound of a shorter wavelength. What is the value of this shorter wavelength? Okay, first off, shorter wavelength means higher frequency from the relationship between the speed of a wave and its wavelength and frequency, which you can find on the formula sheet right here. V is lambda f. And if this is smaller, and the product has to always be 343 meters per second, then this one has to be bigger. So we're looking for a higher frequency. The new frequency, we can say f prime is the frequency, the original frequency, the one corresponding to the 53 centimeter wavelength, plus f beat. Alright, enough preliminary thought about the problem. Let's get to it. In order to apply this, we're going to need to know what that original frequency is, and indeed we can get it from this expression. The V is equal to lambda f. Allows us to solve for f. Just divide both sides by lambda and switch sides. So f is 340. Well, I think let's work with symbols as far as I can. So I got an expression for f. And then substitute that into there. F prime. Go ahead and copy this expression down. F prime is f plus f beat. So f prime, the new frequency, is V over lambda plus f beat. And I got values for all those things. All these are given, so I could go ahead and find f prime if I wanted. But that's not what we're interested in. We want to know what the shorter wavelength is. So we're actually looking for lambda prime, where V, the speed of sound in air, I'll use the same symbol because it's the same thing, for the other frequency is lambda prime f prime. So lambda prime is just V over the f prime. I think I'm going to continue up here rather than scrolling all over the place. Lambda prime is thus V over lambda plus f beat. And so I don't have to plug in the V so many places. I'm going to divide top and bottom by V. So I got 1 over lambda plus f beat over V. Substituting the values with the units. I got 1 over, and then lambda was 53 centimeters. I'll plug that in as 0.530. Plus the f beat, I think was 2.8 hertz. All divided by 343 meters per second. That evaluates to 0.5277 meters. Lambda prime is thus 52.8 centimeters to 3 sig figs. I choose to keep one more sig fig, even in the final answer.